Distances in our galaxy. Little objects orbit larger objects, everywhere. Electrons and protons, Moon and Earth, Earth and Sun, Sun and the center of the Milky Way, and most probably the Milky Way with a whole lot of other Milky Ways spins around the center of Milky Ways, and on and on. Our galaxy, the Milky Way, has a center. It spins around faster at the center and slower more outwards. The Milky Way has two arms with billions of stars each, which have been stretched out over time to the current form. Earth orbits the Sun in 1 year at 30 kilometers a second. The Sun orbits the center of the Milky Way in 225 million years at 220 kilometers a second. Wow! The Milky Way is huge in size. It's 110,000 light years wide and 3,000 light years high in the center. There are 400,000 stars in it. It's big, bigger, and even more bigger numbers. 110,000 light years. Who could have any idea with that? So let's try something else. Let's take a trip of 110 kilometers. That's London to Southampton, or perhaps Amsterdam to Eindhoven. Picture that. That's a 2-hour trip max, right? Okay, 110 kilometers, that's 110,000 meters. The light years and meters are now equal. So, on this scale, 1 light year is 1 meter, is 1 light year meter. If light would take the same trip of 110 kilometers in this model, light would travel at 1 meter every year. Imagine yourself moving at this speed the next time you take this trip. Just to get into your car takes you 5 years. Bacteria breed faster than that, it's ridiculously slow. Let's make the distance of this trip the diameter of a circle. We empty the space and move the Milky Way in. And I mean empty, because the stars are no larger than sand and planets are dust in this tiny scale model of the Milky Way. Every sandcorn represents a sun and is a light in the sphere. Some of these lights are really faint, like glowworms, and others are really bright, like lighthouses. Let's take a closer look. We are right here. A dust near this yellow sandcorn, our sun. Imagine it to be a candlelight. There are other sandcorns close by. Within 50 meters on all sides, there are 65 more tiny lights. So, our dust thingy is some kind of a mess, but luckily we kept our surroundings really clean. The next sandcorn was Alpha Centauri, at 4 meters or 4 light years away from us. Alpha Centauri is like our sun called a dwarf star, because of their insignificant size. Alpha Centauri's position is kind of below the sun. Therefore, it can only be seen from the southern hemisphere. Only because Alpha Centauri is so close, it's one of the most brightest stars in the sky. This totally counts for the number 1 brightest star in the sky. He's not surprisingly another neighbor from across the street, Sirius. He is at 8 light years or light year meters. This one is called a white star. He's of average size, almost twice our sun size. If Earth is a candle, Sirius is a small maglite. Just behind Sirius, in his backyard, another bright star, Procyon, at 11 light year meters. That's 3 meters away from Sirius. The 2 twin or Gemini stars, Pollux and Castor, are at 34 and 52 light year meters away. They are also in our hood of stars. It makes a lot of sense that we see the light of our neighbors better than the light of our neighborhood, or even the next town. Aldebaran is also a bright star. It's on the end of our street, 66 meters away. You might notice that these stars, together with Orion's Rigel, form a sort of a pattern. It's a zigzag. Therefore it's called the Winter Hexagon, because that is what it looks like from Earth. We know most of the stars by the sign of them, like the Big Dipper, the W or Cassiopeia, and Orion. But from every other star in our neighborhood, or even the next town, these lights would have a completely different constellation. Orion only looks like the one we know if you look at it from our point of view. Aliens from another planet most probably never heard of Orion. It only would show them how small-minded we look at the stars. You don't give your tablet light, your smartphone and the street light a name because they seem to form a triangle when you're on the couch, or do you? Having said that, there are stars in clusters, like chandeliers. This is the closest one at 443 light-year meters. It's the Pleiades. They form a group from every angle. There are also really mothership-loading big stars. The lighthouses or giant stars. Rigel is one. It's 800 meters away. Betelgeuse is even closer at 600 meters. It's the top left star in Orion. She's so big, 1,000 suns next to each other are as white as this red supergiant. In comparison with other stars, it's a big star, but on the size of the Milky Way, in our model, Betelgeuse would be no bigger than a little pebble, but still would be one of the biggest structures flying around in the entire Milky Way. So if you lose your way when taking a trip in the Milky Way, search for these supergiant stars. Google Milky Way would advise you to travel from the center of the Milky Way to Orion's arm, then Deneb, that's our town central lighthouse at 2.5 kilometers, then Rigel, Betelgeuse, Canopus, and then towards Sirius. Cross the street and you have arrived at your destination. All the other suns, or stars we see at night, live in our Milky Way. Even stronger, we only see a small part of our Milky Way. Let's check the facts. On the list of the 100 most brightest stars, 40 of 100 are within 100 meters of us. 90 of 100 are within 600 meters of us. Besides those 100 bright ones, there are about 2,000 to 5,000 candlelight stars we are able to see. All of them are within 500 meters. That makes a lot of sense on this scale. If you look outside, you will perhaps see the glow of a city away, but you won't see the individual candles from there, only the ones in your own street. So, the visible sphere of our galaxy is roughly 600 light years in all directions. That's almost every star we see at night. Let's make our model even smaller. We put this visible sphere in a tennis ball. You need 20 more tennis balls to get to the rim of the Milky Way, and 26 to get to the center of our Milky Way. Now, the same amount on the other side. That's a radius of 46 tennis balls. To go around on 2p times radius is 289 tennis balls. Fill it with 6,647 tennis balls, all of which represent tennis balls we are not able to see in our own Milky Way. What? If we want to know what's inside these other 6,646 tennis balls, we've got some work to do. In our own tennis ball, we haven't even visited one other sun, like all of our ancestors before us did, and all the monkeys in the trees. We have only gazed at them.